Thank you everyone for coming. My name is Dan Miller. This talk is titled The Intro to the C# Job System and ECS. If you guys have any questions about this talk or random Unity related things, feel free to reach out to me via email or on Twitter at the handle DanMillerDev. So today I'm going to be going over a couple things about the ECS and the C# job system. First, I'm going to be talking about some terminology and system overviews. Next, I'm going to be talking about implementing jobs and entities. And lastly, I'm going to build a project around the ECS and the C# job system together, and we'll be able to visualize the performance benefits from the new system and the old. So what is the C# job system? At its core, the job system is a way to write multi-threaded code in a very safe environment. This means that when running into issues like race conditions or dependency issues that you normally have when you're multi-threading code, we're able to handle that for you, give you nice error messages and things like that. So it is an API for specifically scheduling jobs. For the entity component system, it's a new way of writing high-performance code by default. It's moving away from an object-oriented approach, which is what is the Unity classic way, into a data-oriented approach. And by data-oriented, what I mean is that we're separating our data from the processes that interact with that data. And when we begin writing code, you'll really see how these are separate and how they interact with each other inside of Unity. At its core, the definition is that an entity is just a lookup index. You can think about it as the database key that is referencing certain objects with components. Components are basically just streams of data. So they're hold certain data types, and then you interact with those components in systems. And that's what makes up the Entity Component System, or ECS. So before we get into how ECS works and what its benefits are, I want to talk a little bit about what is classic. And what I'm referring to as classic here is the way that you interact with objects in Unity today. And what that is an object-oriented approach. You have game objects that you attach components to. You create classes that hold data as well as manipulate that data, and those are objects as well. The data and the processes are coupled together inside of those classes, and it's largely dependent on reference types. So you're often doing things like getting different components and manipulating that data. And the big issue is that the memory layout in the classic system is very scattered. You might have a game object that lives in memory over here, referencing another component and its data that lives in memory over here. And when you go to get those references, you need to load that memory into cache, and that becomes very slow, especially when acting on a lot of different objects or a lot of different components. The other issue with the classic system right now is that you often get more data than you need. In an example here, where we're referencing a transform of a component, we may only care about its position and its rotation. But the object-oriented approach to game objects and mono behaviors that we have inside of Unity means that when we reference that transform, we also get a lot of additional data. You can see we have in each transform things like an up vector, a right vector, a forward, local position, as well as local rotation. And a lot of this extra data comes with you when you're referencing these types. The other issue is that when you're going to instantiate objects and components, that's a lot of extra data that's required in that instantiation. And lastly, the way data is being processed in Classic right now is almost entirely on the main thread. So this is a lot of people or a lot of processes waiting in line being processed one at a time. So now let's talk about how the ECS and the C# job system are different than Classic and what sort of advantages they bring to Unity. For the ECS, what we're doing is we're specifically grouping groups of data into what we're calling entities. And then with that data, we can lay these out in specific chunks of memory. This allows data to be tightly packed within memory, not the scattered approach that we're seeing with object-oriented design. Next, that data is acted upon by systems and is filtered through that. And lastly, we parallelize that data by calling processes on multiple threads in order to optimize and speed up performance. So as I mentioned, the data becomes tightly packed. We're no longer referencing a lot of scattered data, and we're no longer getting extra data. When I'm looking for a position of a component, most of the time, I'm only looking for 3 values, an X, a Y, and a Z. And in the new ECS approach, this allows us to just get that position and just get those 3 floats. So now I'm going to tell you a little bit about how to get started today and show you a couple steps to do that, and then we're going to start building a demo and coding in the new ECS and C# job system. So to get started today, you'll need to download 2018.1, which actually launched today. And you'll need to change the scripting runtime from the .NET to the, from the .NET 3.5 to the .NET 4.x equivalent. Next, you'll need to go into your manifest file, which is basically just a data file that exists with every new Unity project that you have. It's at the same level as the assets folder, if you're familiar with the project hierarchy. Inside this manifest file, you'll need to add these dependencies, as well as these packages that we're seeing down here for things like collections, entities, and jobs. This is going to import some additional functionality into Unity that allows you to start taking advantage of this new ECS and C# job system. So now I'm going to hop into Unity and we're going to start to look at how you build things in a classical way, which I've already built. And then we're going to move over and start live coding in the new ECS way. So in my scene here, I have just a little house, and we're just kind of looking off into the abyss. So right now, I have an object here, and it has a script called spawn snow. And spawn snow is a very simple script written in the old object-oriented approach. And you can see that because we're still deriving from mono behavior. We're saying that this spawn snow class is an object in itself. Inside this spawn snow, we have a public integer for the number of snowflakes that we want to spawn, and a public game object to reference what snowflake we're actually going to spawn. Next, we're just storing a couple floats for random x, y, and z values. And then we also have a couple utilities here in order to visualize how many elements that we're spawning on the screen. In the start function, we simply call spawn flakes. And in the update function, we're simply looking for a key press in order to spawn more flakes as well. Now, the spawn flakes function is very simple and familiar if you've ever kind of spawned objects inside of Unity. So what I'm doing is I'm calling a for loop to loop through the number of elements, and then simply getting some random positions for the x, y, and z, and spawning each snowflake at those random positions with a rotation of the identity quaternion, so 0, 0, 0. And lastly, down here, I'm just updating some of the UI and visualizing it to see how many entities I have. So now let's hop into Unity and check out what sort of performance we get and how we can kind of maximize what we're looking at. So right now, I have this set up, and just to show you what the snowflake prefab is doing, I'll just show it over here. So this is just a tiny little snowflake, and it has a very simple script on it as well. And what this script is doing is just choosing a random fall speed and spin, and then updating its position downwards in the update function, and its rotation around the vector 3 up axis. So now if I hop into Unity, I can go ahead and delete this and go back to my cabin. You can see when I hit play, we're going to start to spawn random snowflakes. So you'll notice right away that in the hierarchy, we now have a ton of snowflake prefab clones, and that's just 1,000 that we spawned. Now, if I hit the space bar, we're going to continually spawning snowflakes, and at about 10,000, you'll see that we're nearing this 30 frames a second. Now this is still a lot of snowflakes, and you can see that they're each individually falling and spinning a little bit there. And depending on kind of how I visualize, we do get some better performance as the snowflakes go off screen a little bit. But keep in mind that 10,000 number. All right, so now what I want to do is create scripts that allow us to code in this new entity component and C# job system way. And as I go through these scripts, I want to mention that while this new way of coding is different, it's not necessarily difficult. It's really about thinking about how to separate your data from the processes that are manipulating this data, and then using some new APIs in order to spawn objects and schedule jobs on them. All right, so in order to start off, I've actually already made a bunch of small scripts, but none of the data or the code has been added to them. You can still see some still have the start and update function, and the only thing I've done is I've gone through and added the necessary namespaces. So some of these newer namespaces are going to give us the ability to interact with these new APIs and call and derive from these special structs. So, as I mentioned, the first thing we want to do is we want to have a data element that tells our snowflakes how fast to rotate. For this one, I'm calling it RB rotation speed. Since this is just holding a data, we don't actually want this to be a class. Instead, we want this to be a struct. The next thing is, since it's a struct, we don't want to derive from monobehavior anymore. Instead, we want to derive from iComponent data. This is a struct entirely for rotation data. And to do that, how are we going to store the rotation data value? That's going to be a simple float that we'll call rotation value. And that's it. This is the data component that is going to store the value for our rotation speed. Next, we're going to go to move speed and make it almost identical as well. And you'll start to see how I'm separating the data and then how we begin to manipulate and process this data in the systems. So similarly, for the move down speed, I want to create a struct instead of a class, and I want to derive from iComponent data. Similarly to rotation, the fall speed is going to be represented by a float value. Just like that. So now we have these two very simple, very easy to understand structs that hold a single float value for the data. Now, the next thing we want to do is we want to create the system that actually acts on this data. The point of this system is to move the snowflakes down. Very similar to what we had in the object-oriented approach, we're going to be adjusting the position value. So in order to do this, instead of a mono behavior, we're going to create a job component system. We no longer need the start and update function, and instead, inside of this job component system, we're going to create a new struct. And for this one, we're going to call it rain move job. And the unique thing here is that we're going to derive this struct from iJob process component data, and then this is where we link up the data to the system. So what we're going to say is we're going to say that any entity that contains a RB move down speed as well as a position component, that's the data I want to process. And for things like the position component here, this is a built-in helper component that we've provided inside the ECS. And it actually comes from this Unity Transforms namespace. So there's a couple basic components that you'll be very familiar with from the object-oriented design. Now, this struct is going to complain at me because in order to derive from it, we need to have an execute function that acts on the data. So for that, we're going to create a public void execute. And here's where we're going to be passing in the values by reference. So we'll call this one speed, and then the position one, and we'll just call it pose. So now that I've done that, this is where I want to take my data that I've already declared and actually process it. So for moving something down, we're going to need a reference to delta time. This allows it to happen and change over time. So for this one, we're going to add a public float called delta time. Now, inside of this execute, what we want to do is grab our position, grab its value, and then grab the y component. And this y component is what we're going to manipulate in order to move it down. So what we're going to say for this y component is we're going to subtract equals the value of speed dot move speed times delta time in order for it to happen and update. Now this is how we are processing this data inside the system. And now let's write how the job is going to act and how we're going to schedule that. So in order to do that, we're just going to go down here and do a protected override on the job handle and we're going to call that onUpdate. And from there, this will allow us to pass in the input dependencies depending on what sort of data we're manipulating. And this is where we can start to potentially assign dependencies if we're manipulating data that another job might also manipulate. For this system, we're simply just manipulating the position there, and this is the only system or the only job that's acting on this data. So for this, we're just going to create a job variable and set it equal to a new rain move job. And then on that, we're just going to say, what data do we need to pass into this job that we haven't said yet? And that's going to be our delta time. So our delta time that we have up here, we're just setting it equal to time.delta time. And lastly, we're returning the ability to schedule the job. So we're just going to say job.schedule this 64, and then pass those input dependencies like that. There we go. So now what we're able to do is, let me just fix that error. What we're able to do here is we have our job handle that's being updated, and we're telling it to go ahead and schedule that job. So, so we don't need a semicolon there. Instead, this gets declared in there. So again, we've set up the move speed as an iComponent data, and now we've made the move system, which acts on that data. And for the rotation, similar to how we have the very simple iComponent data for rotation speed, we're going to set up the system very similarly. So for this one, again, I don't need the start and update function. And instead of a mono behavior, we're going to derive from a job component system. Next, we're going to create a private struct, and we're going to call this rain rotate job. And again, we're going to derive from iProcess component data, and this is where we say, what data do I want to manipulate? And for us, that's going to be RB rotation speed, and then simply the rotation. Now, again, we're going to want a public float for delta time, which will pass into the job handle. And our execute is going to be similar to what we saw in the other one, and similar to how we rotate objects, except there's a couple new APIs that we need to keep in mind in order to get the data correctly processed. So for this one, we're just going to pass in our rotation speed reference and our rotation reference. Now, for this one, all we want to adjust is the rotation value, similar to how we adjusted the speed value. Now, traditionally in Unity, you are able to multiply quaternions by quaternions in order to get back the value. Because the way the new ECS is set up, we have to use additional math APIs to do that. So to do that, we're just going to call math.mul for multiply and pass in a normalized value of the rotation value and multiply that by the axis angle, similar to how we did the rotation before. And so this is where we're going to pass in our up, which again is using the new math library for math.up, as well as the variable amount, which is going to be our speed dot speed value or rotation value times delta time. Just fix that there. So again, we've created a rotate job that's going to allow our data for RB rotation speed and rotation to be manipulated and then processed. So similarly, we need to make sure that we add the job handle to tell it how to schedule the job. So for this, we're going to do another protected override. On update. And we have that kind of auto-completing. And this is called the rain rotate job, like this. And again, we're just going to be passing in the delta time here from the normal function there. And lastly, we need to make sure that we're returning this so that it gets scheduled properly. And that's not how that works. There we go. And we're just going to be passing in this, 64, so you can see, and lastly, the input dependencies. So you can see here, when it's auto-completing, that this second integer is basically the batch of that we're going to be doing. So for this one, we're saying, hey, get as many of these snowflakes that you can and start batching them in quantities of 64 as we schedule out these jobs, and we start to parallelize them on multiple threads. So right now, I've set up the data and the systems, and the next thing I need to do is start to combine these and tell them exactly how to act, as well as spawn the entities that control these systems. Before I do that, I want to hop into Unity and show you how to set up a entity inside of Unity using the new entity component system with a familiar workflow. So to do that, I'm going to create a new object here, and I called this one, or I just hit Control-Shift-N, which creates a new object. And actually, I'm going to go to a new scene really quickly in order to more easily show you how this works. So I've created a new object, and now I'm going to start to add some components to it. So the first one I want to do is an instance mesh renderer component. And when I do that, you'll notice that off the bat, it adds a game object entity script. Now, there's a lot of these kind of helper components that are basically wrapped around mono behaviors that allow you to act in the more traditional workflow that you might be used to. Once I've added this mesh instance renderer, this is where I can assign a mesh and a material in order to be rendered by this entity. So for this one, I'm simply going to click on the mesh and find my snowflake. And for the material, something to keep in mind is that the material needs to be configured for GPU instancing. So you can see this little checkbox down here that says Enable GPU instancing. That's what's going to allow me to render it on this instanced mesh renderer. Next, I'm going to add the transform matrix component. This is going to give it the ability to be seen in the actual scene. And lastly, I'm going to add a couple other components here, like my rotation component. And once I add that, you'll actually be able to see the object in the scene here. Now, because we're dealing with entities and we're not dealing with game objects anymore, you'll notice that the position at which I put this object is not actually affecting where this snowflake is. And when I start to spawn these snowflakes in the new entity component system, you'll notice that currently they don't show up in the familiar scene hierarchy. Instead, we've built a special window called the Entity Debugger, which you can see here, and I'll be showing you guys a little bit how to use that in the future. So now that I have this game object here in the scene, I'm just going to rename this to something like Entity Snowflake, and then now apply it as a prefab in my scene, or in my project. If we hop back into the cabin scene here, now we're going to go ahead and create the manager that spawns and manages these entities. So if we're hopping in code here, this script is going to be a bit more in-depth and have a couple different parts. To start, I'm going to set up some very basic functionality for things like spawning snowflakes based on the spacebar button, similar to what we had with the old system. So first down here, I'm going to create a function called spawn snowflakes. And then in the start, we're just going to call that right away so that we get some initial snowflakes. And then in the update, we're just going to check if the user has hit the spacebar key. And if so, we're going to call spawn snowflakes again. Next, in order to really understand how we're spawning snowflakes and how many we have on screen, I want to make sure to hook up this system to the 2D UI that keeps track of how many entities have been spawned. So to do that, I'm going to create a public reference to a text object, which is the UI in the scene. I can do that using the UI namespace and just creating a public text field here called entity number text. Next, I'm going to store a private integer that also keeps track of that. So number of ents, and we'll set that to 0. Now, inside our spawn snowflakes, this is where we want to update these numbers. The other thing I want to do here is create a public integer for the number of entities to spawn. How many do I want to spawn in my scene? And for now, I'll just set that equal to 1,000. So now down in spawn snowflakes, this is where I'm going to add the, this is where I'm going to increment this number of ents to my numbers of entities to spawn. And then I'm just going to take this entity number text and display the number there. So right now, this doesn't really have anything to do with the entity component system, but this is just giving me some ways to hook it up to the kind of debug scripts and the visualization that I already have in the scene. So in order to start acting on these entities, what I'm going to do is I'm going to create a public game object that holds a reference to my entity. So I'm just going to call this snowflake ent. And this is that entity that I just created in the other scene. So now what I want to do is inside of my spawn things, or spawn snowflakes, this is where we're going to start working with these entities. And the main thing to keep in mind here is that we're going to use an entity manager to spawn entities. And then we're going to loop through those entities and set values for the specific components that we've added to it. Or we're going to add components to it at runtime and initialize those with values. So in order to do that, we're going to first create an entity manager. And in order to do that, we're going to use this world API. And it basically says get or create a manager, and we're going to call that an entity manager. So this says, similar to something like a singleton, hey, if this thing exists, give it to me. If it doesn't exist, let me create it right now. Next, we're going to use a native array. This is a lower level data type that allows you to interact much more efficiently and easier inside the new entity component system. For this native array, we're just going to make it full of entities, and we're going to call it a snowflake here, and just initialize it with the number of elements that we're going to spawn. And we're also going to say that we just want to allocate this native array temporarily. These allocations have the ability to be temporarily allocated as well as persistently allocated if you want them to exist throughout your entire process or your entire application. Now for this one, we're just going to say native array, spawn a bunch of these entities, and then after, we're just going to dispose of this array. So after we've done that, now we need to pass these to the entity manager. So we have this here, and in here we're going to say instantiate, and for that we're going to use our game object up here, and then we're going to say go into this snowflake array that we've created. Now we're just going to simply loop over all of the entities that we have. So we're just going to create a simple for loop here. And inside of this for loop is where we're going to start to kind of initialize these components that are on our entity and give them these systems so that they can start to act on it. Now, before I get into that, I want to make sure that I'm not leaking memory. So I'm actually going to dispose of this native entity array down here, just like that. And one of the nice things about the new entity component system is that it gives you a lot of these error messages for you. If you don't dispose of this here, there's going to print out an error message that says I'm leaking memory. So now that I've done that, let's start acting on these data. So in order to do that, we're going to get the entity manager, and we're going to add component data to our entity. For this one, we're going to be looping through the snowflake array. So we're just going to pass in the variable through there. And now we're going to add a new RB rotation speed component that we've already manipulated with our system. So from there, we're going to initialize the rotation value. And for this one, we're just going to kind of hard code something like maybe 0.5, like that. And what this is doing here is we're saying entity manager, loop through all these entities, and then initialize it with this component to be a new rotation value that's going to be set from there. So it's saying that my rotation speed can't convert from a rotation speed to a unity component type. All right. So for this one, let me see here. So I think we can just do a rotation speed like that, and then do the speed value. All right, so I'm going to go ahead and I've added, so here's the issue. So let me turn it back to what it was. I was trying to add a component, but really what I want to add is a component data, because this RB rotation speed, if we look at it here, is simply an I component data. and it's holding just a reference to this rotation value. Similarly, we're going to want to do the same with the data for the fall speed. So we can do snowflake there and add a RB move down speed, and then from there we're going to initialize this to something like 1.0f. Now, right now I'm just choosing basic normal values, but the nice thing here is that I could easily initialize this to some random value. And you'll see when I show off the demo here in a moment, you'll see how once you add a little bit of randomness, it really helps sell the effect. So the next thing we want to do is I'm going to create a random position component in order to have the snowflake spawn kind of in this more dense array here. So for that, I'm just going to create a new float3 type, which is similar to the native array. It's this new data type, much like a vector3 that you might be familiar with, but much closer to the hardware. And we're just going to call this starting position and initialize it with a random range between 0.1f and 100.0f. And we're just going to do this for the x, the y, and the z, so that everything spawns kind of in this area here. Now, with my entity manager, instead of adding the component, now I want to set the component data. I've already added that position component to the entity when I created it. So I'm going to set the component data on my snowflakes. And from here, I'm just going to say a new position and set this position's value to be the starting position I just created up there. All right, so that was kind of a lot of code, but the gist of it is that we're creating an entity manager. We're creating a native array of entities, and then we're looping through the entities and either setting component data or adding component data. And because we're manipulating this data in these systems already, once we add those, they're going to start interacting with the elements. So now let's hook this up inside of Unity. Looks like I have a small error somewhere. Oh, on my RB rotate system. So I forgot to put a semicolon at the end there. So now what I'm going to do is inside my Unity editor, I'm just going to add this new system that I created, which is called the RB Rain Manager. And now you'll see that we have a reference to the game object that we're going to be spawning. And for that, we're going to do the snowflake ECS that we created earlier. And lastly, we're just going to hook up this text in order to visualize how many elements we have in the scene. And let me just make sure I'm grabbing the correct text here. Oh, so this is the one that we're going to want to hook up, like that. And now I'm going to turn off the old system, and we have our new system here. So we'll say ECS, snow system. And let's see if it works. So you can see right now we have 1,000 entities. Let me go back to the cabin. And as I hit space, you'll see that I'm spawning entities. Now, the thing to keep in mind here is that I'm locked at 60 frames a second, and we're at 11,000 entities. And I can continually add, and you'll see where it's still at 60 frames. There's a little bit of jump, and now we're starting to kind of go below that. So let's see if we can get to around 30 frames a second. And we're starting to get there. And you can see up here in my Unity scene just how many entities we have. And these are each independently moving down and rotating. And it's obviously getting extremely dense in here from all the entities, and we're still at around 30 frames a second. Now, the one thing to keep in mind is that because we're creating entities and we're not creating these game objects like we were in the past, in order to visualize and understand where these entities are, you need to use this new entity debugger window. And from here, you'll see that we have all of our different systems happening by name. So you can see the rain mover system, you can see the rain rotate system, as well as our entity manager. And here is where all of our entities exist. So you can see I can really go through each individual entity, but the power and the ability of this entity debugger is really so you can check on your entities. Similar to how you check on game objects in the traditional workflow, this allows you to click on them and then visualize exactly what's happening. So you can see each individual component that's been added to this entity, as well as the values being manipulated on them. So one last time, I just want to show we're at around 40,000, or I can just bump it up to 40,000 entities, and we're at around 30 frames a second. Again, these are all in the new entity component system and using jobs. If I go underneath, you can see just how dense and what performance we're able to get. And switching it back over to the older system before, and again, I'm just using the normal instantiate, everything's an object, each snowflake is its own object. Right when I get to around 10,000, then we're capped at 30 frames a second. So you can see just by reorganizing your data and using these new APIs and using these new systems, you can get upwards of a 4x. There's also things depending on how many entities and components that you're manipulating and how much of your system you move away from the object-oriented approach into the data-oriented design. You can really get upwards of 10 or 100x depending on the complexities of your project. Now, the last thing I want to end with is the entity component system and the C# job system right now in Unity are going to exist alongside the traditional object-oriented design. They're going to be worked on kind of in tandem, and what we're doing at Unity is we're taking a lot of this ECS knowledge and piping it back into the inner workings of the engine in order to optimize and make performance better across all platforms. The last thing I want to say is just some additional resources if you guys are interested in learning more. There's the GitHub page with a lot of entity component samples that we have, as well as the newly launched features page on our website. This features page gives you a high-level overview of the entity component system, as well as the C# job system, and it links to a lot of our Unity YouTube channel that has a lot of really good talks by people like our CTO, who has worked really hard, and this is one of his biggest efforts, is to kind of move towards this data-oriented design. So with that, I think we have a couple minutes for questions, but thank you all for coming. Pure ECS, more faster than hybrid ECS. I haven't personally done performance test on that, but I would guess that a pure ECS system is going to be a little bit faster than the hybrid. So you are going to be creating a lot of those entities all through code, but just laying out your data in this data-oriented design, in this pure ECS way, you're going to get a lot quicker and a lot more efficient just in general, because you're specifying exactly what data you want to act on beforehand. The next question is, can we entity data transfer from job component to other job component? So yes, there is something where you actually have, you basically have shared data or shared components where different components are looking at them. Now, depending on what you want to do with that shared data, you can set it to be something like read only or write only, so that only a specific system can act on it. But yes, there is the idea of kind of sharing this data between systems, because that's important, just in building applications in general, is being able to have different systems look at the same data. All right, so I think my time's up. I am going to be around for the rest of the conference, so if you have any more questions, feel free to reach out. Thank you very much.